Well, hello everyone, and welcome to our webinar, Making Energy Evaluation Easy for the Architects. My name is Camille Chamy from CADcentre, and for our attendants who don't know me, we are located in Eastern Canada. We have offices in Toronto and in Montreal. Joining me today is our guest, Andy Thomson, architect practicing in Ontario, who's been applying his expertise in passive house design, zero carbon, since 1997, right, Andy? Andy, thank you for being with us today. I really appreciate you participating in this webinar. Also, we have our friend Zoltan Toth from, he's a key account director at Graphisoft North America. He's joining us from Philadelphia. Hey, Zoli, how are you?
Hi, everyone.
The reason why we're doing this webinar, for us, it's important for the architect to know, to implement energy evaluation from the earliest stages of the design. It has a tremendous effect, positive effect on architecture. And using Archicad, you can do that from within your BIM model with a very streamlined workflow. Today, we have Andy will run through the key concepts that will make, that the architect needs to have in mind while doing the energy evaluation. All the aspects that he needs to know to optimize the process, preferably in a linear way. We'll be doing a live demo, comparing different models of the same project in order to optimize it. And then we're dedicating some 15 minutes for the Q&A to address all your questions. So if you have any questions, please fill them in, and I will stop sharing my screen, and Andy, please do yours. Just a small note before Andy starts. This webinar is being recorded. So if there's anything that you feel is unclear, if there's any topic that you find unclear, please come back and watch the recording, and this way you'll be able to grasp all the items that we are covering. Thanks a lot. Andy, the floor is yours.
Thanks, Camille, for the introduction. I'm overheating here, but there's a reason for this, the hat and the glasses. I would get into reading all the stuff we're going to do. It's actually too much information to get through, so we'll just skip reading slides. We're not going to do that. But I'll jump right into how this is going to work. What we need to understand is that energy modeling is like three-dimensional accounting for energy. And there's all these flows coming in and out of a building. And it's super abstract if you're only thinking in terms of the number and the BIM file. So we're going to try and take all the concepts and bring them down to the level of a human body. So we all understand, thermal insulation, air tightness layers, appropriate glazing, shade devices, and the rest. And so the part of the purpose of putting this material together, we've probably got a full day workshop here, but we'll condense it down to an hour, is to show how our new building codes in Canada, how we can work to hit those targets in the software that we have. And if you're joining us from the United States, you can easily switch between feet and square feet and BTU units. We're going to be using meters, meters square and kilowatt hours, because that's what we're using in Canada and in Europe and almost everywhere else. Let's not get into that subject. So effective in 2024, we're going to be losing the Ontario Building Code SB10 and SB12. It's going to be replaced. Those whole sections are getting rescinded, and we're going to be moving over to the NBC 2020 and the NECB 2020. and those are for part 3 and part 9 buildings respectively. So the targets that we're aiming for, unless you do lots of performance modeling, is going to be about 0.24 for walls, that's a U value, 0.138 for roofs, and 0.15 for floors. What does that mean? There's a whole bunch of terms. Oops, I'm going backwards. There's a whole bunch of terms that we'll be using throughout the session. These are some of them. We're going to make a PDF of the slides later, so you don't have to kind of take notes or worry about all this stuff. But EUI is kind of the first one, and it's the most important one. It's how much energy is the building using as a function of its area in a given year. So that's the intensity part, it's per square meter per year. Then there's TEDI and cooling demand intensity. GHGI is how much carbon is the building emitting in a given year. Heating degree days, cooling degree days. The conductivity of a material. So when you touch a piece of aluminum, it's cold. That's the K value. You feel that. The U value, that's the rating of the assembly, but it can also be the rating of the layer of the assembly. R value, which is the reciprocal, or 1/U value, which we're used to specifying for walls and roofs and things. GWP is global warming potential. LCA is life cycle analysis, the hot topic now. And then BIM and BEM, we know what BIM is. BEM is just building energy model. So anytime we refer to BEM, it's just the energy model part of the BIM program. So sometimes I put a little red dot in the units for thermal resistance, just so we can think about it as stopping. We're stopping energy with that assembly. And the U value is like the transmission or the power loss through the assembly. That's like the green. It's kind of like a permissive value. And transmittance is similar, so those are green. So again, U value is reciprocal of R value. We're used to R value. So if we're talking about an R23 wall in imperial terms, that's an R4 RSI wall, and so on. So back to this, U value is like transmission, and R value is stopping power of the assembly. So in the overall accounting of the 3D model, you see lots of these diagrams. There's lots of energy and arrows and stuff coming in and going out. But effectively, you're looking at the building as a system, and it's receiving energy, and it's rejecting energy, or losing energy, as the case may be. And you have cooling. In Canada, we have a pretty strong cooling season. And then this kind of all reverses, and then we're trying to dump heat out of the building and prevent gains in the summer. So that's measured against cooling degree days. So all an energy model is doing is kind of mapping the flow or the flux of energy in and out of the building. And this is the from the key values section of the report of EcoDesigner within Archicad. And it shows you basically the energy balance. So how much energy is coming into the building system, and how much energy are you losing through either poor insulation of the walls or through air systems or windows or whatever. And the goal with a good energy model is to flatten the gains, like squash the middle of the graph, so that you're not gaining tons of energy in the summer when you don't want it, because that results in a cooling load. And then in the wintertime, you want to limit those gains. So sometimes I refer to this graph as kind of the double happiness. That's the goal. You want to kind of flatten those gains in the middle in the summer, raise those gains in the winter, or like it's a falcon. And then minimize your losses on those two sides of the graph, which are the winter for us. And I think you probably invert this or something for like if you're in New Zealand or Australia. So this, I can finally take this gear off because this little girl can do my job for me now. All the stuff relates to stuff that we can, all these concepts rather, of energy loss and air tightness and thermal bridges. We can bring that right down to the level of a human body. Now she's showing us our shade device, appropriate glazing, air tightness measures, her scarf, insulation in the form of a puffy jacket, ventilation. You can just take your jacket off or unzip it, and you should be able to do the same thing with a building without even running a fan. And that can be tied into your operation profiles. We'll get into that. Thermal bridge avoidance. Nobody wants to have a cold button, or you could pull your jeans out of the dryer, a hot button touching you. So that's another thing to consider. Thermal bridge avoidance and appropriate foundations. Those are the key concepts, and we apply them on every building. So if you think about this little figure, this is the person or the building with that shade protecting layer to limit summer gains. This is the wedding facility we did in Innisfil, just south of here. So we've got these verandas that limit solar gains in the summer, but permit all of the gains in the winter. So we're basically building a solar oven to bring in as much heat and light as possible in the wintertime, but then block it entirely in the summer. And we've done a whole series of these buildings where we've kind of been experimenting with minimizing the surface area of the building, making it thermally really efficient because we've got the large volume, but the small surface area. So good area volume ratio, AV ratio. This slide's really important because we can make a terrible mistake as architects if we say to a client, your building is going to use $2,000 worth of energy, or it's going to have an EUI of 500 or 200 or 50 or 1. The problem with that is what we do with an energy model is we're optimizing the model from a reference case. So we pick a year, and that year could be 2020. It could be 1971. It could be a future weather file from 2030. Those are radically different weather scenarios, and depending on what weather file I choose, it's going to have an influence on my overall energy, just from my reference model. And this plays out in real life. So we should always be using the term optimizing. We're optimizing energy from a baseline or a reference model. We are not estimating, we're not predicting, because there's just a chaotic number of variables that are involved in that, from user behavior. Here's one example. We built a building on the left, that's my house in Quebec, and then we built the same building in Ontario. And we clocked out an EUI about 50 of the building on the left, so 50 kilowatt hours per meter square per year. And then on the one on the right, when the client's energy bills came in after the first year, their EUI was 103. So why this huge discrepancy in the energy yields? Well, for one thing, they had the temperature set at about 26. They love it hot. They spent most of their time in their underwear. The guy is a welder, so he's modifying trucks and stuff with an arc welder, and they got a hot tub you can see over in the corner there, and their sauna and a bunch of other loads. So user behavior can really drive a huge difference between what you were kind of targeting as your reference model and the reality. In our case, the EUI of 50 was less than 80, which was the predicted from the reference model, just because we're really conscientious users. We use hardly any water. We run our thermostat at 18 degrees Celsius. We set it back at 15 at night. We ventilate instead of running air conditioning. So these are all things that are super important in an energy model. So here's just an example of 3 different years, 2016, 2017, and 2019, where if you took our energy bill of 12,000 kilowatts for 2016, and then 7,900 kilowatts for 2016, 2017, and then 2019, it was 9,000. That's a 20 to 30% variability just between 3 years of energy bills. So to say, yes, we can accurately predict the loads that a building are going to use, kind of, not really. You can predict it against a reference model, a typical weather year, but you can't predict what the weather is going to do in that next year. That said, looking backwards, it's easy to target or put an EUI number to a building. And I'm just going to jump out of my slides here and go to our web browser at teui.ca. This is the calculator we built for the OAA, the Ontario Association of Architects. And you can take a building, let's put 300 square meters in here. And let's say our building used 12,000 kilowatts of electricity. I have an EUI immediately of 40 for that building. Now, if I use propane or wood or heating oil or something else, let's just say we had 10 cubic meters of wood. I can see my carbon emissions of that building have gone up. Now we're at 73 EUI. So this is a really handy tool for putting all the units in terms of kilowatts, because I could also put in propane. Let's say I used 1,000 pounds of propane in a year, and let's get rid of or bring down the electricity use to 4,000. Now I can see my EUI for that building is 68. So this will help you get a handle on what is a good EUI and what is a bad one, right? So worst performance is up here, that's about the 600s, and passive house is much lower than that, like around 60, 50. 120 in terms of primary energy. And then you run the simulation period for that year. So this is generating EY just by taking the total energy use and dividing it by the area, and that gives you the intensity. So we have a new version of this that's under development, and this is called TUI.2.0. This will be in the PDF, so you can get the link from there. But the difference is now we're looking at what building occupancy am I looking at? Am I doing a detention facility or residential? Let's put residential, and I can put a location in here. Well, I'm in Barrie, so I'm going to choose Barrie. That's automatically filled out the heating degree days. And then what compliance standard am I targeting? Tier 1, 2, or 3 of the National Building Code, NECB 2020, which is the part 3, or passive house. So when I put these things in there, I'll start to get a pass-fail for whatever units I'm putting in. So let's say I'm, 15,000 kilowatts of electricity. That converts it to BTU, so you can see what the difference is doing there. And then, so I start to get an EUI right away, which is 54 gigajoules of energy per year, divided by my building area, which I haven't put in, sorry. Building size, 400. Okay. So now I've got a total energy use intensity of this line right here, 37.5, right? That's how this works. Now it goes further. There's all kinds of other metrics we can put in here. So when you scroll down, there's like heating degree days, cooling degree days, and then you put in all the building information, the envelope area. And that's telling you the U value of your wall, the U value of your roof, the U value of your floor. So what's the rating of the jacket that your building is wearing? And then it compares that, runs it through the heating degree days of the year, and tells you what the predicted energies would be. So I will close that one. Those are in development, but it's a great way of seeing, is my building going to be compliant with the building code? So back to the slides. Oops, there. So this is an example of where we took a customer's utility bills for renovation, and we said, we're going to benchmark their existing building in EcoDesigner, right? And see, so I'm not even in Archicad yet. I'm just taking their energy bills, putting all the data that they've got in there, and I'm going to try and find out what their EUI of their building is, and then make Archicad match that value from the reference building that we've modeled. So we put in a system, you can see here, energy source, of a mix of 41% electricity, 38% propane, and 21% wood. And presto blammo, we get exactly the EUI that was predicted by the backwards-looking EUI calculator. So the next step is basically to developing that concept further. There's a lot of data that can go into this. And so we just said, well, how can we simplify the optics of what it is we're presenting? And if you look at a nutrition facts label, it's really clear on a box of cereal or yogurt or whatever. So we're kind of trying to do that with the sustainability facts label. And that's the 2.0 version of the OA calculator. And it includes life cycle analysis data like the embodied carbon of the building structure itself, indoor air quality metrics, water use, offsets, as well as the thermal values of the envelope, and how is it comparing against the building code requirements that we're submitting for. So again, this is our building in Quebec, and then we've got a label that we can apply on our title block of how this building is performing. So there's the new version. We've got all this extra stuff that's going to be launched in the summer. And another tool, which is really helpful because you're only going to get a high performance building if you're using high performance assemblies. And we were seeing that there's a problem of kind of getting a generalized high level overview of a given composite or assembly that you're making in Archicad. Just as a quick oversight, like I don't know what the U value of that thing is going to be. I've got a stud cavity, 3 layers of foam, and some wood cladding. So we built a label. This is the team at Enzyme in Hong Kong and Madrid with our participation to do this. So I'm going to get out of the slides and go to our template file. So in the template file, we've got a whole PDF. We did a research study for National Research of Council of Canada, and we took about 100 different assemblies and we applied a graph. And this graph is like an automatic label tool. It's actually pretty cool. You can download that. It's $50 from the Enzyme store, which I will show you what the link is. If you go to weareenzyme.com, they've got a shop link, which is just /shop. And then here's the energy pack label. You can click on that and see what it does. And I'll give you a very brief demo of what this thing does. But in the screenshot here, you can see it is comparing the global warming potential of the material. So that's embodied carbon. The thermal conductivity provides automatically, but just by shifting the units, and then embodied energy of that assembly. All this data exists within Archicad for any given assembly. So we have a lower story, right? It's just underneath all the work that we're doing, where we kind of put a little chunk of all these different wall assemblies, and then we can apply these graphs to the assembly and find out what its values are. So this is a label, and I can just hover over this wall, click on the wall, and then I get a label that is showing me any of the combination of these things. So global warming potential is derived immediately. If I open up the label tool and I look at what the values are, I can see that I can toggle between thermal resistance, embodied energy, or GWP. So based on a review of all of these assemblies, then I can find out what are the best ones to use in my building file. So we have a biogenic one here where we've got Gutex wood fiber insulation boards on the outside of the sheathing with a GWP of -12. So because it actually inverts the carbon impact of that material because there's more stored carbon and less manufacturing process carbon in that material. So when you go through the whole list, you start to learn all kinds of interesting things. There's two walls that we compared as a function of a study for the building code, where we took the standard wall in Ontario. If you go into any residential subdivision, you're going to see this wall, 2x6 fiberglass insulation, 1/2-inch plywood or OSB, and an exterior layer of foam. And if you look at the GWP or the impact of that material, it's 87. So that's the carbon footprint of that material. And we have a U value of that assembly of 0.172 or an R imperial of 33. So using our label tool. And if I look at a similar wall where I've taken all the insulation, I put it outboard of the plywood, we've got 3 layers of GPS or graphite infused polystyrene. I can see immediately I'm going down to a 2.7 global warming impact of that wall assembly. And I'm getting a slightly elevated performance level, 37. And this is using cost tracking from ContraVim. So the price of this wall per square meter is $226. And this one is $226. Same price, higher performance, way lower carbon. So we can meet 2030 and 2050 goals if we just are smart about it. And when you start using those kinds of assemblies in your portfolio, you will find that you're going to get much better results for the building. So there's 2 buildings we're going to look at right now that are on the books. They're going in for permit in about 2 weeks. And they're from a succession of buildings that we've been optimizing. Every year, we get clients that come to us and say, we want a custom house and it's got to have 6 bedrooms and whatever. And we say, well, do you really need all that? Because if you use our services to optimize a building we've already done that might meet your needs, we can save you a lot of money on fees, and we don't have to redo all the performance analysis and the structural engineering, all the rest. And so most clients, when we tell them that, they say, oh, okay, let's look at that. So the floor plan for this one, the way I modeled it is we've just got one zone and we called it thermal. And it is like a net area zone that we then trim to the shape of the building. And the best way to do this is the automated little thing, but you can do a manually defined zone, like one where you go click, 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 and create the polygon for it. That works just as well, as long as it's touching all the surfaces of the building. So what does this look like in 3D? This is basically a south-facing building, and we have fewer windows to the north, more windows to the south, and we plug this one zone in here. And then on the upper level, we've got a couple of bedrooms in a loft, right? 2 bedrooms and a shared bath there. And we did another version of this building, and we're kind of curious to see, well, this one. Well, what if we modeled it differently? And we put a kitchen, living, dining zone that's all one big space, it's double height. And then individual separate zones for the bedrooms and the mechanical room and the bathroom and that. So that works as well too. But the one zone method of modeling is quicker. It's just faster to process for Archicad. So what these look like in 3D, I'm going to just pop open the 3D window. I've got this kind of a big space with the kitchen, living, dining, and this huge curtain wall and an upper level to that curtain wall. And so kitchen, living, dining, hallway, loft upstairs, bedrooms, a central corridor, and then less doors and windows to the north. So when we set up a model like this, that's what we're calling the barn, kind of the barn flavor of this building design. We also have like a curved glue lamp version of the same building footprint. So I'll just open that one up here. So we use clones for views for cameras. So I'm basically opening the same view, different model, but this is kind of stripped out all the furniture and stuff because I don't want to see that in my energy model. If I look at the render view of the same thing, camera 6, sorry, that's the framing camera. So we do this actually for everything. We've got like, just show me the structure, or show me the way it would be rendered, or show me how we want to see the thermal model. And in the thermal model, we want to have the zones switched on in the 3D view. So capture those in the energy model dialog. And then I go to design, and at the very bottom here, I have energy evaluation. And that's where I can open up the energy evaluation palette. Boom, there it is. So there's a thing called a thermal block. A thermal block is sort of a confusing term, but it is the overarching set of brackets that basically collect up all your rooms or your zones. So we have rooms as architects, we apply a zone within that room, and the thermal block captures that and applies an energy system and an operating profile to those 2 things. So you start building up the model with the thermal block and you add all the zones to it. So in this thermal block, I can see I've only got one zone, right? Because that's the method I use to just give me a quick analysis of the building file. So what does that look like if I go outside of the building? There's a little cube up here. If I switch that on, I can see this is what the zone is capturing, right? That's the whole volume. Is that correct? Well, I want to kind of look at that. So we've got these 3 tabbed pieces up here: structures, openings, and thermal blocks. So I've got structures, and I've got this tree view, and I've got a list view. I can pick on the list view, and I can go one by one to see how EcoDesigner or Energy Evaluation has captured all the surfaces. Did it get everything? So if it didn't get everything, and I can pick all of them to see that all together, right? There's my structures and there's my openings, right? I want to make sure that I've kind of got the whole model defined. So all the windows are captured, all the structures are captured, and all the zones have been included in this thing. So sometimes you will get structures that are have a high value or a low value. Let's look at that in the other model. So if I go to this barn format, and I'm going to switch into my view, the same general view, but with my zones switched on, and all the interior walls and furniture and all that kind of stuff turned off, and I launch my design energy evaluation palette, click the button there, up this thing comes. So it just does a little read of all the zones. It's captured all the information it needs now. And I can see in my thermal block, I have captured all of these different rooms. So what does that look like in 3D? That's my whole block. Just gonna move this guy so I can get into my orbit. Right, and individually, one by one, I can kind of click through these and make sure that I've got kind of all the zones identified that fill the whole space. And then I can look at the structures. Yes, I've got all those. I can go through them one by one if I go into the list view. Right, and then I can look at all the openings. So I can click the whole thing and make sure they're all there. When I'm sorting through this, I can look, if I stretch this a little wider, oops, I can see that I've got these U values, right? For every given piece of structure, I've got a infiltration level of 2 and a U value that's 0.15, 0.13, and then I've got this one thing that kind of offends me. I don't know what it is, but it's high. It's like 6, right? It turns out it's a backsplash from the counter. And what happens is when I start the energy simulation and I run this, so I just hit run the analysis, it goes through and it calculates for every hour of the year, energy coming and going through all these different assemblies. Now it's not going to care too much about this stainless backsplash in my overall model because it's not facing outside air, it's not doing anything. But what I can see is that here in the thermal block key values for my external elements, I've got 6.45 as the U value. So that's throwing off my key values. So if you find these things, I call them trout in the milk. If you find kind of an offending U value, you want to kind of isolate that thing and kill it, get it out of your model. So all we have to do here is go back into my layer combination for my thermal layers and find out what layer that's on. Oh, it's on cabinets, right? I really don't need to see cabinets in a thermal layer combination. So just switch that off. I'm going to hit update, and then I can run the analysis again. So I just go here and update energy model review, boom, right? So now that it has reviewed all this stuff, my, whoops, it's still thinking. There, my stainless backsplash went away. And when I run my analysis, I will see that I don't have any of those problematic U values anymore. So getting the zones to touch all the surfaces, making sure you've captured the whole picture of the model, making sure there's nothing too high that's beyond those values that you're expecting is an important first step. And then we can get into running all kinds of different analysis to optimize the models. So what I've done here is, like, I have a question. Is the curve shape going to give me a better building performance, or is the barn shape? I've got 2 slightly different assemblies, but I've got a different volume. It's more volume on the barn shape and less volume and less surface, or more volume, less surface on the curved shape. Which one's a better performer? That's the overarching question. So I'm going to toggle between these 2 models and see which one comes in at with the best number. Energy consumption, this line right here, that's our EY. So why is it so low? It's only 10. Well, because I haven't put any systems in yet. All I want to do, and the first thing I want to do with any model, is run the model with no systems. So in my thermal blocks, I don't want to have, let me get my zoom controls out of the way here because they're kind of blocking what I'm looking at. So if I click on this and I've got my list view here, I can see that for this thermal block, I don't have any mechanical systems assigned. That's the way you want to start. I don't know if Archicad starts by applying systems, but you don't want to have anything in there. And I'll tell you why. So now when we run the model and we get this dialog that says, do we have a baseline building? No, we'll get into that later. First, we want to make the building as good as we can or meet the building code, and then we can do reference model stuff later. So I'm conscious of the time. I've only got 15 minutes to get into this. So I'm going to give you the quickest overview I can of how to compare these two models and what we're going to change to make them perform better. So when I run the analysis, here it goes. We get a report. I want to kind of switch on all of these things that are in the report chapters. So by default, this might be closed or it might be minimized or something. We want to make it big and we want to kind of make sure that we have all those check marks on. And the most important one for us right now as architects is to look at the temperature profiles for the year. So all these things that are kind of pink graphs, right, that are at the end. I put them at the end of the report so they're all together. And if we look at the one here for December 21st or solstice, we can see the blue line is what the interior of the building model is doing. And we can see the dark blue line is what outside is doing. So outside is like -20. And inside my building with no energy systems at all, no heating, no cooling, no ventilation, nothing going on, I'm at a reasonably comfortable 10 degrees. It's not going to kill me. But it's not close to the outdoor. Like I'm getting a moderating effect of the building, which is what you want to see. It would be even better if I can get it up into the 20-degree range, but I haven't set anything to help me do that yet, and I haven't really optimized the building yet either. So, and then you can go through the different months and see, well, I'm not going below 5 degrees. I'm probably at around 10 degrees in January. This is with no heating system. This is just architecture. And I've made this building as poor as I can, right? I've limited the assemblies. I've made it really leaky. I've done all kinds of stuff so we can go through the progressive improvements. And then when I scroll to the summer months, I can see we're getting into May. Now I'm at like 30, but I'm over 30 degrees Celsius inside. And outside is only like 10 to 15, right? The outside air temperature. So the really easy way to get the indoor temperature to match or be closer to the outside is just open a window, right? Dump that heat. That's an easy line to get down. So I'm not going to worry too much about it right now, but I can see it would be a problem in August when my internal temperature is approaching 50 degrees Celsius, right? Like that's going to cook my occupants. I don't want to do that. But this is the first thing we should do with analysis. Just study the architecture and see how we can get these lines to be as close to within the range of comfort of indoor temperature, 22 heating season and no hotter than 26 in the summer, without doing anything with mechanical systems, only evaluating the envelope. So if I go back to the key value section at the top of the report, what I see is energy consumption is nothing because this is just plug loads from the occupant profile. It's not including any mechanical systems yet. But what I can see is I've got these things in the thermal block for the HVAC thermal block key values, unmet load hours. So this is what is called unmet load analysis. I can see that I've got 2,556 hours of unmet heating and 4,000 hours of cooling. So this is a really good building from a heating point of view, but not a really good building from a cooling point of view, which is what you start to find when you're doing high performance building design is cooling becomes one of the critical issues, not so much providing heat for the winter. We can solve that easily. Just don't make a nice thermos that's not losing energy. But how can I make the heating even better? Well, I've got assemblies that are giving me an air change ratio of about 3 air changes at 50 Pascal difference. So that's what's called a door fan test value. So I've got a door fan on the building, suck all the air out, and I can measure the pressure difference at 50 Pascal. How much air is flowing through the fan? That's 3 air changes per hour. So I need to get that down. If I'm going to be targeting passive house, I want that to be like 0.6 or lower, or R2000, it'd be 1.5. But generally, I need it to be like in the region between 1 and nothing, right? Like a spacecraft is close to 0. So, and then I look at my building shell average value is 0.23. So good, passive house is looking for about 0.15. And then I can check all my assemblies, my windows, and make sure that those are as optimized as possible. So how do I increase the air tightness of the building? Well, if I go into the structures tab of the energy evaluation panel, and I stretch it a little wider, I can see that these have an air infiltration, a normalized leakage area of a certain value of liters per square meter at a certain pressure difference. Usually it's 75, and that assembly is tested. So if I say, well, what if I make this more like 0.2? And if I click all of these items and I make a change, it's going to change all of those lines. So this is kind of what I would be targeting for passive house. So let's see what difference that makes. Start the energy simulation, run that again, and let's see what my air changes at 50 Pascal would be for that line and the key values. There, I'm at 0.38. So that's the kind of number we typically hit when we're running the door fan tests on our buildings, because we make the detailing really simple, where it's easy for the trades to get a nice clean membrane wrapping the whole building with very few penetrations. And then when you run that door fan test, you're going to find you're going to get numbers that are targeting passive at 0.6 or lower. 1.5 is still pretty good though. Now, when I add energy systems to this, I'm going to see that I'm going to get better performance. But right here in the winter, I will probably start to see that just based on tightening up the air leakage, I'm getting a better indoor temperature. Now I'm above 10, I'm at 13 in December, right? So I'm seeing that I'm getting that heating season number line higher without doing anything but changing the envelope characteristics, right? If I add more insulation, it'll get better and better. So let's get out of here, and I'm going to start adding systems to the building. So if we go into our thermal block and we click on that first level, I can add a basic heating system. So the way I got to that dialog right here, come on, zoom controls. There's a little button here that's plus or minus, and then there's the systems dialog there. There's lots of ways of getting it. You can also get to it from this little gear and go to building systems there, right? So it brings up these things. So I've made some really basic systems. If you open EcoDesigner, they'll be called gas boiler or electric space heater or whatever. I call them Acme just to make them really generic. And the first thing I want to do after I've run my unmet loads analysis is put not yet specified. So for any system I'm going to put in there, whether it's a heat pump, electric space heater, oil fired boiler, air conditioning unit, not yet specified is the thing you're going to do. So we've established how many unmet hours we have for cooling and heating. Then when I put in, like, I can put all these in at the same time. I'm just going to go, give me a space heater and give me a, let's do it from here. Space heater, air conditioner, heat recovery ventilator. Boom. All three of these are applied now. So if I look at what the space heater is doing, I can say, well, it's just electric resistance. I don't care what it's doing. All it's going to do is match those unmet hours, right? The unmet heating and cooling hours from my air conditioner and my heater, respectively, right? And I've applied those, this is important, applied them to that thermal block. So I have to hit assign and click thermal block. I've already done it once before, so I don't have to do it again, right? It's already right there. So now I've got a heating system, a cooling system, and an HRV, really basic systems. Click the not yet specified button, and then hit start energy analysis. No baseline building, continue. And you can ignore these zones errors. They come up all the time. Just got to make sure that you've captured all your elements when you review them in the structures tab or in the zones tab. You can see that they've been captured. So when you run the analysis and you hit the not yet specified systems, you're going to start to get loads. So I can see here, I've got in my energy consumption line, again, that's our EUI line, our total energy use intensity in kilowatt hours per meter square per year is 92, because I'm using systems now that are using energy. So I start to see these numbers. My unmet load hours, right, which were 2,000 and change for heating and 3,000 or 4,000 for cooling, they're solved now. They've been addressed by my systems that I added. And I can see what my peak loads are too in this thermal block key values. Heating peak load is 6.24, so I'd be meeting passive house with that. And cooling is 9.57. So then I can go back to my systems now that I know that I've got a peak heating and cooling, and I can assign those kilowatts to the systems. So I can get more precision with the mechanical system because the software has told me how much energy I need to provide to make up for those loads. So now when I scroll down to my temperatures, what I'm going to see is a ceiling and a basement. And what I mean by that is the building mechanical system will no longer let the temperature fall below 22 Celsius. So I got a flat line there. So I'm not freewheeling the temperature. I'm like holding it to 22. I'm not letting it get any colder than that. That's what applying a system does. And it will do the same thing in the cooling season, where when I get into April, I'm kind of coasting there. I'm not applying the cooling yet. But as soon as we get into May, we're starting to get high temperatures. I'm limiting that to 26 degrees Celsius. So I'll show you how to set up the operational profile and the thermostat for all that kind of stuff next. But that's the upper limit. I'm not letting the building get hotter than that. So take care of the architecture first. Try and get those to within a comfortable range without putting a mechanical system in. Then apply the mechanical system not yet specified, and the set point temperatures for those things. So I'm going to close out of this, and I just want to see, well, how did I tell it to deal with a heating season and a cooling season? If I click on this heating season thing and I go to apply to thermal block, actually I want to be in operation profiles. So that's this one. So in the operation profiles, I have this advanced one that I made. You can have there'll be a basic one in there that's every hour of the year, but you can start saying, well, what is the heating season and what is the cooling season for a given building? That's my advanced. So I've got Ontario heating season every day from September 30th to April 31st, which is 4,392 hours. In the year, we've got 8,700 some hours. And then we've got a cooling season defining run the cooling only in these times. And then I can look at the daily schedules and I can see this is a dialogue that allows me to say when people are home, what's the occupancy density of the building? Is anyone home? Are they not? Do I have a minimum or a maximum temperature that I need to do the thermostat? All these things have a building code correlation. So the code will tell you it can't get any hotter than 24. I put in 27 because ASHRAE lets us get away with more. We won't be allowed to do that anymore in Canada. That's being taken away from the building. It'll be 24 as the cooling set point, probably because Environment Canada or NRC realized that climate change means we've got to deal with cooling more. So there's our heating and our cooling season and what our lighting power density is and what our equipment loads are going to be. This should be a 5. But all these things, you can pull the tables right out of the building code, plug those values into these things and run your operation profiles. That's how the heating and cooling systems work. So what other kinds of things can I do now that I've got these systems defined to increase the energy performance? Well, one thing I could still see is I've got a pretty high cooling load. So now that I've defined a basic cooling system, I run the analysis again. And I'll jump back over to my other model, this curved one, right? And we'll run the analysis on this guy. Let's do the same thing we did before on the other structure. Okay, so this is my other file is done now. So if I look at the EUI, I've got an energy consumption of 92.81. It's okay, it's not great, but I still got a pretty big whack of cooling energy, right? This net cooling energy is 42. The heating energy is only 22. So I got to work at getting that cooling down because that's my higher load. If I look at my peak cooling demand, it's 9.6 kilowatts, or my heating demand is only 6.2. So how can we get that down? Well, there's a lot of gain, right? In that south-facing window. This is that yellow, that double line, that double happiness. I want to squash that in the middle. So I've got some pretty good ventilation going right now because I've told the profile to do that, run ventilation, dump as much of that heat as I can, but I still have to cool. And that's these little blue things here. Oh, sorry, the dark lines are cooling. I'm sorry, I haven't applied my ventilation yet. So the cooling energy is the highest load that I'm looking at my overall file. If I go energy consumption by targets, 8,300. So what will happen if I close out of the report dialog and I apply some kind of shading element for that south-facing stuff? Well, I've got a layer that I made that's got shade stuff on here. So I've got exterior shades. So look for inner thermal layer combination. I'm going to switch on exterior shades, and that turns on this thing. So now if I go into my openings dialog, I'm going to go into the list view. I'm going to take questions in a minute, but let's just review the solar analysis, and then we can take some questions and then come back to this when it's done calculating. I'm going to go open analysis. Well, I can't see what window I'm talking about yet. So let's separate that one. That one is okay because it's got all that roof shading, but this one might be a problem. So if I go open analysis, I can see I've got this yellow stuff spilling into the middle, which means this is a mask of what the window is seeing. So I don't mind that it's on the right and the left because that's my winter, but I don't want to be gaining this much energy in the summer. So if I click on the hourly contribution of energy, I'm getting like up to 2,000 watts coming in through this window in the shoulder seasons, and I want to kind of shade that out. So having the window shade elements will change this graph. Anything anything, whether it's a tree or a shade element or an exterior wall, I can use stuff to help me shade to get that analysis to optimize. So I'm gonna hit recalculate, and that's gonna go through and calculate about 600 polygons and figure out the shade value for every hour of the year on that window now that I've applied the shading to it, because that's on in the layer now. So maybe I'll take some questions. I'll stop screen sharing just for a sec. And what are we looking at, Zoli?
Yeah. Andy, just a small note, there's a raised hand. So let's start with that. Just a minute. I'm kind of like trying to figure out the person that rose his hand, if he can ask his question. Give me a second. Well, while I'm figuring it out, let me ask some questions that came in from the chat. How well does modeling work when a building is hotlines into a complex site with third-party vegetation and multiple buildings?
So if you have, it depends if they're attached or not, but if you have multiple buildings, you probably want to model each one independently. So you'd save out a separate file, like if it's a complex university campus or something like that, it's residence and a restaurant and some of those buildings have radically different UIs. So if there's a different occupancy, you'll want to model that separately because there's a different operation profile, there's all that stuff. But the site is the same, the weather files can be the same. If you got a lot of vegetation, I would kind of hold off on modeling with that because it's polygon intensive. And it really, you need a very powerful machine to crank, because it's doing shading calculations for every hour of the entire year for every leaf on a tree, right, on a given window. So use blocks to simplify things, in the first round. You can refine the model later on, but I would schematic level modeling is going to give you the better numbers right out of the gate. So separate the models based on occupancy, do the simple zone method first, and then you can give individual zones and kind of put those into a thermal block. But I would just run it as one zone and just see how your envelope is performing. What are the walls and the roof and the stuff that's facing the ground doing? Run that analysis and then progressively refine it as you go through the process.
Thanks, Andy. How does the Archicad energy analysis compare to F280-12, if you know values?
So F280 sounds like a CSA standard. Archicad, when they developed EcoDesigner, benchmarked it to ASHRAE 140. That is what our building code is looking for. So if you review the NACB 2020 or the NBC 20, our new codes that are replacing provincial codes, they're not looking for methodology that's tied to an F standard. They're looking for compliance with ASHRAE 140, which is not a certification standard. It's just, here's all these test cases, like a shoebox with a south-facing window. And when you run the analysis, you have to be within 5% of all the other softwares or within the expected DOA baseline building, and then your software is essentially compliant. So this is compliant, but the critical things are to use the right weather file. So that's massively important. I can't even underemphasize how incredibly important that is, because if you're using outdated weather, you're going to get outdated results. Oversized heating systems, undersized cooling systems. It's a real problem, and it's well recognized in the building modeling communities. Right now, even our 2020 codes are referencing data from 2005, which is already obsolete. So our brand new codes are referencing obsolete data. That said, we need to use that data set for code compliance, but we should be running analysis for a 1.5 degree global mean warming scenario right up to 3.5. NRCan has just published all new weather files for us to access to run that analysis. And then also we have to make sure that our building materials within Archicad are properly defined. Because if we use material, let's say fiberglass or rock wool or something, and it's got the wrong U value, your whole model file is going to be off. So that's something you have to go in and kind of check. There's some good baseline values that are in the software right out of the box. But if you're going to be accurate and precise about it, you need to make sure your weather files are current and your building materials are properly defined. Any other questions before I jump back in? Yep.
Do you want to jump back in? And let me just ask one question, because this was the same person that was asking are we actually now telling HVAC contractors what the heat gain loss is and sizing equipment?
Well, I'm not an engineer, so I'm not going to start doing engineering, right? That's my scope what's usual and customary for me is envelope. So what I'm going to do is I'm going to say to the engineer, we have energy modeling software we're using, and it's telling us our loads are X. So this is where you start the conversation. You know, we're not doing your job for you, but given that our software is coming up with this number, what is your software coming up with? And we had a really interesting test case, that wedding building that I was talking about in Innisfil, where the engineer's model was coming up with 22 tons of cooling required. And our model was showing we needed about 7 tons of cooling. So it's not that we are engineers and we're trying to do engineering, but we just have a question for the mechanical engineer. How are you getting 22 and we're getting 7? Well, it turns out they hadn't anticipated we had physical shading devices that applied to limit gains through the windows. They had full sun coming in all summer long, right? They also hadn't anticipated these were triple glazed windows. They used a code minimum value because they're always concerned about meeting the code minimum. Well, we have triple glazing, so what effect does that have? They also considered that the activity level of the participants within the building was active or dancing, like partying, right? Whereas most of a wedding ceremony is sitting, milling around, having a drink, all that stuff happens later when the sun goes down. So when we started to break down what the engineer's model was assuming versus what our model was assuming, we started to find a way to communicate together to bring their loads down. By the time they added the U values that we had for our assemblies, the shading, the activity levels that we anticipated, and all the other factors that we had considered for our model design, their model predicted 7 tons of cooling. So we're not doing engineering, but we're using the early stage building energy model to have an intelligent conversation with our sub-consultants about what the predicted loads, I will never use that word again, what our targeted loads were, so that we can work together to optimize and coordinate. Because normally what happens is the architect does their work, they hand over the building to the mechanical engineer, they run analysis, and by that time the client's paid all kinds of money, they don't want to optimize, they don't want to value engineer, and that's baked in, right? And all the performance manipulation you can do is tweaking mechanical systems, the efficiency of a pump or a fan or something like that, or LED lighting or whatever. It's too late to make these sweeping big changes to the entire envelope. So it looks like there's 17 questions in the Q&A now. Maybe we'll just take some of those, because I don't know how much, I'm not going to have a lot of time to get through more energy model optimization, but
what I suggest, what I suggest, Andy, just do an extra 5 minutes with the software, and then maybe we can go a little bit over time with some of those questions.
Okay, sure. Well, so once we've done our unmet loads now, we've done our freewheeling or our unmet loads analysis to determine, is this a cooling scenario or is it a heating scenario? And then we've applied our basic systems, not yet specified. I'm not an engineer, I'm not going to guess at what those are going to be, but those are systems that are going to match the loads, right? It's pretty easy stuff. I'm not going to offend any engineer by having the model tell us that. And then I can get into kind of fine tuning stuff. And typically I would lean on an engineer to say, well, I've put some basic systems in now to this model. Let's open up that tab. So we get this here. We've got our Acme generic load matcher, right? This is not yet specified cooling and all that kind of stuff. We can then go in and kind of specify data about what that system's doing. So on-site equipment, is it a boiler or furnace? How many watts? Well, our model software told us that. What's the energy source? It's going to be 100% electric. Okay. And we can say it's a heat pump using external air. And what's the load? Well, we need it to do cooling too. So I'm going to put a 10 kilowatt load in there. What's the heating system efficiency? So my engineer can help me with this stuff. And is this system also going to do our surface hot water heating? Well, I don't want to burn anyone. So our building code says 49 Celsius, 10 on the cold side. Okay, now we have a more accurate heating and cooling system. And we can specify the, based on F326 ventilation modeling, what is our operation schedule for our energy recovery ventilator or our heat recovery ventilator for an occupants 2 in a space with 2 bedrooms. 90 CFM unit might be doing it fine. It runs all year 24/7. So those systems then apply, and we can run the analysis again and see, are we improving our EUI? So this model I have not yet improved the air tightness of the structures. So I still should be showing a pretty high ACH 50 number. That's one thing that I can see the difference right away. So I can look at this and go, my energy consumption of this model is 76, right? But I've got this offending 3.2 ACH. So what happens? Can I get down from 75.9 just by tweaking the airtightness of the structure. So I'm going to go back into my structures tab, list view, select all these guys, stretch this open so I can see everything. And I'm going to change these to 0.2. So this is all normal and customary for an architect to do. We're dealing in envelopes. So we adjust that, and then we say, okay, run the analysis again. And we're down to 0.42 now, and our EU consumption has gone down to 59. So pretty easy way to have a pretty massive impact on building energy modeling. So depending on what standard or what level of building code you're targeting, you can adjust the airtightness of the assemblies to give you the air changes per hour at 50 Pascal, that number. And you can progressively go through the model, making these little tweaks and changes until you get your EU optimized. And I can scroll down now to my temperatures and see, well, I'm not letting it get too hot in the summertime, and I'm not letting it get too cold in the wintertime. But I let it kind of freewheel in the shoulder seasons, so I'm getting temperature line because it's fine. It's not going to kill me, right? The cold or the heat. I'll leave it there. There's a lot of material here, and I could show you how to model a hotel or a restaurant or a house or whatever and optimize it. But now with Archicad 26, eco-designer or energy evaluations is incredibly fast. Like it used to be really pokey, so slow. It was no one have coffee and come back and check the analysis. Now it does it in like seconds. So it's really powerful software that lets you do quick analysis and optimization of an envelope right out of the gate with even the most basic model. If you just use one zone, run that a bunch of times, get it kind of optimized before you even start talking to your engineer. This is the goal.
Thank you, Andy. We have a tremendous amount of questions and a couple of raised hands, but Zoli, would you like to go through those questions?
Thanks, Camille. Well, I just wanted to take a minute first to thank Andy, not only for the presentation, but for being a longtime user and champion in our community. We appreciate you, sir. Also, I wanted to thank you, Camille, and CADcentre for hosting this webinar about something that's so important to our community. And just kind of wanted to reflect a little bit that Eco-Designer came out about 15 years ago, if you can believe that. And about 10 years ago, we included the base level functionality in the out-of-the-box Archicad. And starting with 26, like you mentioned, Andy, all of this functionality is available to all of us here out of the box. So I think it's my main takeaway from the presentation, really, along with the great sophisticated, ASCA GDL tool that Andy made along with his partners, is that there's a combination of two things that makes energy evaluation unique in the market, I think. And those are that it can be used from a very, very early stage to inform the design, just like you reiterated that, Andy, a minute ago, especially in terms of passive solutions, right? Optimizing building shape, materials, and so on. And at the same time, it fully leverages the building information model to create the building energy model due to its integrated nature. And there are some questions about IFC compatibility here, which we can answer later in email. I also want to thank everybody for attending the webinar. It's so nice to see so many friends here from Canada, a lot of people from Toronto, the US, Hungary, Argentina, the UK, Denmark, Portugal, Singapore. I'm sure I'm missing a lot of you. I apologize for that, but it's so nice to see so many friends, but also a lot of new people. And for the new people here, I would like to encourage you to go into your work environment and go into the settings. And there's a nice little green earth icon that you can add to your toolbar. Please do that today and join our community. I will share in the chat a couple of resources where you can go to learn. Thank you all.
Thank you.
I see Jared Banks has asked a question. Do you mind if I answer that one?
Go ahead. Go ahead.
So this is a common problem or issue, I guess, with energy modeling in Archicad is we do a lot of like raised concrete stem walls. Like it's the boots and hat method of keeping your foundations dry by elevating them and then starting the framing above that. So sometimes that'll mean that the floor or the bottom level of a zone is kind of crossing over a stem wall with one set of assemblies and then a framing wall with another set of assemblies. So Archicad doesn't, like EcoDesigner doesn't deal with that well. So what we'll typically do is we'll make it one or the other. We'll flatten down our stem walls and just make the regular walls go all the way to the floor. If the U value is the same, it's not going to offend anything. And then we'll run the analysis. Or we can make a zone that's almost like, think of like a water level that floods up to that level. And we call that lower portion of the living room. And then we have an upper portion of the living room. So then the model captures the stem wall condition, and that captures the one that's above. So that's how we can get it to deal with two different composites. There's all kinds of hacks and workarounds about how to get the software to recognize the stuff. But you're right, Jared. We can't use like a renovation, like existing construction, and then tack on an insulation layer and have EcoDesigner capture that. It won't. It'll miss it. So what we need to do is have a composite that is, the existing building, and then we need to modify that composite to add the insulation to that element. And we can filter it out with graphic overrides or a layer or something like that, and then just run the analysis again. So two separate composites are not going to get captured properly. It has to be one contiguous composite. So if your roof is built of lots of different layers of stuff, you might want to just not make a composite that is, like for your energy modeling, just a simplified composite that has all the stuff in it that you need. I hope that helps.
Okay, so are the thermal bridge values and shading analysis generated in Archicad acceptable to be used for passive house? Are there other values that can be usefully exported for PHPP?
So interesting questions. I mean, the way PHPP defines shading, like you can't do a PHPP model without like filling out PHPP. You have to do it. So you can look at the data that EcoDesigner gives you and say, well, I'm getting the same thing. But the EcoDesigner hourly analysis of a window is far more sophisticated and advanced than what Passive House is asking for in terms of geometry for a given year. And our building codes in Canada, at least, in different jurisdictions, they'll ask for PHPP and they'll accept that as compliant. But the way our national codes and our provincial codes are working out now, PHPP doesn't really form part of it. They're looking for other things. They're looking for results from an hourly energy modeler. And all of the specs and the requirements for operation profiles and everything else are clearly defined in the building code. And PHPP, currently it doesn't meet the building code requirements for those things. It might if the Passive House Canada or other people make an argument that it should, but right now it's not on a compliance level. So what we're doing in Archicad meets code, but it's not the same thing as PHPP. And I wouldn't say there's great utility in that. Like EcoDesigner will export a partially completed PHPP, but it references a really old workbook. It's like set version 7.0 or something. There are going to be efforts made, I'm sure, to remap all the values that come from EcoDesigner to the current version of PHPP, which is like 9.6 or something like that now.
Yeah, just we're going over time, Andy. We can answer some of those questions. I don't think we'd be able to answer all, but they would be integrated inside of the recording just in case somebody wants to jump off. There is somewhat a dilemma when our built environment design is based on a sealed envelope, which creates issues related to IEQ and IAQ, due materials and building system use versus any thoughts?
So this is kind of a question I would hear in 1970, 1980. We are providing controlled ventilation exclusively, dedicated 100% of the time through either a combination of fresh air through the windows, or in the heating season, we've got an energy recovery ventilator. Those are built into the code. Those are requirements for F326, all this kind of stuff. So we have to provide fresh air through a system of some kind. In the summertime, I can use my window, but if I've got allergies, I might want to run it through the HRV or the ERV. So the goal is to control airflow, not to have uncontrolled airflow leaking through windows and leaking through building components. We want an airtight building. We want a spacecraft. And then we can run the air systems. It can be a really simple through the wall HRV that's like, just providing heat recovery for us, but it has no ducts. or we can run it through a ducted central system. But that's going to happen. And obviously, if we're using, let's say if we have concerns about indoor air quality, we're going to specify materials that are not going to be a problem for someone, that are not emitting tons of urea formaldehyde or adhesives with tons of acetyls or alcohols, things like that. So it's a function of you specifying healthy buildings, having dedicated ventilation 24/7, but controlling air leakage through the building envelope. We also have durability issues, right? If your building components are leaky, the moisture-laden air on the inside of the building is going to find a way to condense inside that stuff, and we're going to get mushroom farms, and you're going to have a worse problem of IAQ because you're going to have mold spores in your air because your buildings are rotting. So you need to control that stuff by making it airtight. So I would argue make it as airtight as possible, but control ventilation. I did want to come back to that PPP question about thermal bridge analysis. That's a whole topic we didn't get into. The thermal bridge analysis in Archicad is meant to weight what is called a psi value, PSI, which is a linear thermal bridge around a perimeter. So like it could be a wall-to-floor connection or anything like that. It's the big stuff. It doesn't do point bridge analysis, which is a chi value. But it does a pretty good job, and it's designed to be compliant with the ISO standards for that. That said, Passive House certifiers have said they wouldn't accept the thermal bridge analysis from Archicad because it doesn't specify that it's ISO compliant. So that's a whole other conversation. Our building codes are not asking for ISO compliance for thermal bridge analysis. It's just a really good tool to downweight assemblies at a roof, at a wall floor connection, or a window assembly or whatever. So we can use that to just bring down or increase the U value of the given assembly that we're looking at.
Thank you. And I just need to add that we want to optimize the architecture. PHPP certification is a different topic. Maybe Zoli can answer this. Is it possible to make an analysis with an IFC model that has been created from Revit?
So I don't know how well Archicad reads the composites. I haven't done a lot of import and analysis that way. I don't see that it couldn't be done, but you just have to make sure if IFC is bringing in the building material characteristics like the thermal, the transmittance, the K values for whatever insulation or plywood or that kind of stuff. If it comes in and those values are blank, the analysis is going to be useless. So I would say it's probably not the way you want to model something. You're going to want to build up using Archicad-based components within there. There's tons of, there's other modelers you would use. I think if you're doing a Revit model and you want to do energy analysis, unless you're doing the whole project in Archicad, what's the reason for doing just the modeling piece? I would use like Open Studio or something like a DOE-based engine for that analysis.
Thank you. How important is layer management? Pretty much, and general tips you may suggest. Just answer the first part.
Yeah, there used to be a bug where if you had, like I have lots of layers, like maybe, well, not lots, 3 for me is lots, for managing zones, right? So I might have a gross construction area, I might have a net construction area, I might have a net room, layer for zones. And it used to be that the zones would trip over each other in energy analysis, and the gross would compete with the other, even if you had the layer off, and you would get wrong results, or it wouldn't record, or the program would crash. That appears to have been addressed as a bug. So now I can have different zones on different layers. I don't have to use fill to calculate area for GCA. So having the right zones that I want to look at in my energy model view is important. I want to turn off the ones that I'm not considering. So a layer combination that's only including the stuff you want to participate in the energy model is important. Everything else should shut off. Furniture, a little model of a cat, like cars, all the stuff that I don't need. I don't want to see that in my energy model. Just the exterior walls and the windows and some shade devices, and pretty basic model, and the analysis is just gonna be a lot faster because all of that other stuff doesn't really play a big role in the coming and going of energy through the envelope.
What about buildings in Quebec? Can it still be used? Of course, but
so the Quebec building code is a derivative of the national building code. So anything that complies with the national code is good. Quebec hasn't yet adopted the NBC 2020. They will. It's a model national code. So all the provinces. So we signed a fair trade agreement with the United States, USMCA. And as part of that, there's a harmonization process going between all the codes, all the regions. Because if I'm a window maker in Seattle, I want to be able to sell to someone in Vancouver. And if I've got a hokey bunch of different codes for every province and every municipality, I can't have that and have a fair market. So what we're doing is harmonizing all the codes to one baseline, and that is the new codes. So we've built all of our templates and all of our files to correspond to those codes, which will be in effect probably in 2024. I don't know when Quebec is planning to implement NBC 2020 or NECB. NECB stands for National Energy Code for Buildings. That's really just the Part 3 stuff, but it's probably on the same timeline as every other province because of USMCA.
Thank you, Andy. Why not be prepared from today? Is it difficult to adjust out of the box Archicad energy tool to do this analysis? So
no, I think out of the box it works. Yeah, it just doesn't work super well because you haven't been super specific about all the building materials. That's where if you're going to build your own template file, and we will be selling this stuff later in the year. It just takes a lot of time to kind of organize a proper template and make it all work. But you'll want to get an EPD or a cut sheet from the material you're using and check the K value for that material, right? And make sure the building material that you have in Archicad are the same thing. It might be slightly different, higher or lower. So whatever products you're going to specify, you want to kind of match your building library, your building materials within Archicad to align with the real stuff. We assumed a value for glue laminated timber. I think the density was 700 kilograms per cubic meter. And the actual value is 500. So there's some of those things you kind of have to adjust to make sure you're going to get the right values. But yeah, it takes time. It definitely takes time to develop a good template. We will be making a template everyone can purchase and get a lot of this stuff already corrected out of the box. We're also localizing Design LCA from Denmark. So the team over there has done a fantastic job creating a life cycle analysis tool. And all you need to do is pair the materials that we use in our template with what they've done with full scope analysis of A through D of embodied carbon, production carbon, installation, all the rest. And then you can just click a little library object and boom, you get a full life cycle analysis for your whole building.
Great. How accurate?
So Olu is asking this question. So I had a slide that said, we're not predicting future performance because there's just so many variables with weather. That said, for a given weather year, I mean, it's as accurate as going to be. If your weather actually happened to be exactly the way you put it in your energy model and your users behaved exactly the way you've defined them, it would be accurate, to within 2% probably. But the fact is, in the so-called real, this is the difference between the ideal and the real. The philosophers have been going on for several thousand years. But we're not predicting and we're not estimating energy use. We're optimizing energy use based on a target file and a reference case, with a given set of user behavior that is defined in the code and a given set of weather files that is defined in the code. So that's the best we can do with respect to accuracy. With respect to the eventual realities, my own experience is, and I've designed a lot of buildings and lived in them, is that it's very close to, if I put in my user behavior, the way I use a building and all the characteristics about the building and I run the analysis, it's pretty darn close. You're going to get what you expect. But your users can be all over the map. They might leave their windows open all winter. They might, be ballroom dancers and run the thermostat really cold. Who knows what they do, right?
So Andy, we're getting to 1:15, almost 2 minutes from there. There are still many questions.
There's this one here. I'd like to I can read
them.
Go ahead.
I'll
kind of get to them really quickly. So Stephen is asking, do we need to manually enter the weather data material or the current libraries in Archicad good enough? So if you put in the latitude and longitude of your building site, it'll find the nearest weather file based on some somewhat out of date ASHRAE file, which it will pull from something called a Strusoft server, which is Strusoft set up the VIP core energy modeling engine with Archicad. So it'll get a data file that's close enough for government work, right? But it's not going to give you precise weather files. If you want to be precise, and we are always precision oriented, you're going to want to look for what are the current future weather files. You want the hottest year on record, you want the coldest year on record, and you run your analysis with those extremes. So you might use 3 different weather files, one for the building code, one for an extreme hot scenario, and one for an extreme cold scenario. And then kind of find out, what is my building doing with respect to these different scenarios? So yes, it's good enough, but if you want to get into precision, then you have to use a current weather file.
All right, superb. So getting a lot of appreciation for for the webinar. Thanks a lot, everybody. Thank you, Andy, for this. Thank you, Zoli, for being there and helping us out. And Andy, I believe that the information that you shared is really precious. And as we mentioned, everything will be recorded. And Andy promised a small PDF to kind of sum up a little bit of the links and information that he has. Andy, thanks a lot.
Two questions that I want to address. One is about how does this compare to Cove Tool? I love the people at Cove Tool. They have an excellent software, but it's very basic compared to what we have in Archicad. This is an advanced hourly model that does a million things more, probably and better than a lot of the more basic analysis tools are. So a web-based, server-based analysis gives you a pretty good overview, but it's just dividing the area and the thermal values against the heating degree days and maybe some other files, but it's not doing hourly analysis, except for some of the daylighting functions. So we've done modeling with Cove Tool and with EcoDesigner, and we're within 5% of the overall range, but we just get a lot more data out of the EcoDesigner workflow than we would from a Cove model tool. You can't really export granular data from Cove Tool, and we can't really use it as an hourly energy modeler for our building code, whereas EcoDesigner within Archicad can. Ransom asked a question about if you're hiding interior partitions, do they not participate in thermal mass? That's correct, they don't. But they tend to have an effect on reducing the overall U value, because anytime you have a wall punching into an exterior wall, you're taking away the interior air film of that thing. And so it's going to downweight your U value, which you want, it's fine, you can do it. There's also a sort of interzonal transfer, like if I have an attached garage or a sunroom or something that you're losing energy to and from, it's important to include them, but that's for a more refined analysis. So you can include them, it just, the processor takes more time to calculate the results in that case. So that's the difference.
Great.
Oh, people want to know what the difference between the barn shape building are and a curve. I don't know. I'm going to have to do this future workshop to follow up with you, but this is a burning question for me, and I want to kind of know. But we're going to have to do probably a longer workshop. This could easily be 4 to 6 hours of energy modeling, where we give you the tools, we give you the labels, we give you a bunch of template files, we'll set you up with all the stuff. So that's something I think we should probably plan for the future, but it might come from Graphisoft. You tell me, Graphisoft.
It's either Graphisoft or CADcentre. We could, if there's a demand, we can supply. All right. Thanks a lot, Andy. Take care.
Thanks. Take care. Bye.
Bye-bye.